Okay guys, so I'm doing this quick video to show us the relationship between the binomial coefficient and the beta function. Now I've done extensive videos on the beta function, the properties, and so there's quite a bit of information on beta function, which is a very versatile function. But in this brief short video, we just want to look at what is the relationship between the binomial coefficient and the beta function. So let me begin by actually recalling what the binomial coefficient n choose k is. If you recall, that's n factorial divided by k factorial n minus k factorial. Okay, so we all know about that one. And of course the parameters here, k can be 0, 1 up to n, and of course n is typically like the sample size in statistics. Okay, now the beta function that I'm interested in here, call it beta with parameters alpha, beta. I'm not going to give you the integral form of beta function, so I'm just going to write it as a combination of a bunch of gamma functions. Okay, so it's gamma alpha, gamma beta over gamma alpha plus beta, and this is what we want to manipulate in order to explore the relationship between them. And the reason is because here k and n are integers, right? So for that reason, we can actually use the properties of gamma function. One of the property of gamma function is that if the argument of the gamma function, namely alpha, beta here, are positive integers, then we can write them in terms of factorials. And that's exactly what we want with the binomial coefficient, because it uses factorials. So this would only work provided alpha, beta are positive integers. Okay, and I will write that here for reference. So we assume that alpha, beta are elements of the set of positive integers. Okay, now what we're going to do is we want to actually evaluate this for certain combination of nk's, because that's what our binomial coefficient involves, nk. So if we actually let alpha be n minus k plus 1 and beta be k plus 1, related to binomial coefficients, then we can actually use the relationship I just displayed above to write it as n minus k plus 1, subtract 1, make it factorial, and then k plus 1 also, we're going to subtract 1 from that, and factorial it, divided by the sum of those two parameters, minus 1, which is n minus k plus 1 plus k plus 1 minus 1, and of course that would be factorial. Okay, now we can simplify this one. So for example, there we just have k factorial, the ones cancel here, these ones cancel, and of course down here, that's nice, the k's cancel, so we end up canceling a bunch of terms. And we're going to get this nice compact expression that's k factorial by n minus k factorial divided by n factorial. All right, well, that kind of looks like the binomial coefficient, right? In fact, in the next step, we should be able to figure this thing out. Now, if I actually, let's see, okay, so I need to work this thing. Let's see, that's n plus 1 factorial. Actually, I just noted right in here. Okay, so I need to work this another step, one more step, and we'll get to that n factorial. Okay, so in fact, n plus 1 factorial is n plus 1 times n factorial. Okay, so if I multiply both sides, the left side and the right side, if I multiply both sides by n plus 1, I'm going to lose the n plus 1 in the denominator on the right side, and instead I'm going to have n plus 1 on the left times the beta with parameters n minus k plus 1 and k plus 1 equal to n would be k factorial, n minus k factorial divided by now n factorial. And we are almost there. So this is the right side is the reciprocal of the binomial coefficient. So we're going to flip both sides here. So when we flip both sides, the left side becomes, well, remember, I'm switching right and left sides here. So n factorial over k factorial, n minus k factorial is what that becomes. Remember, that is the binomial coefficient, and choose k. Okay, and the right side, of course, remember we did the reciprocal. So it's going to be 1 over n plus 1 times beta of n minus k plus 1, comma, k plus 1. And that is the going relationship between the binomial coefficient and the beta function. So just as the gamma function for integers describes factorials here, it turns out that the beta function can define the binomial coefficients, of course, after you adjust for the parameters, or some call it the indices of alpha and beta. But this is what we wanted to show for this video. So I hope you enjoyed this. Again, this is very nifty, interesting relationship between the two. And it's interesting how these things kind of work together to make up other expressions that are very common in our usage. Thank you for watching, and I hope to have you in another video.